As long as there are underground mines in operation and miners working in them, there will always be the need for highly trained personnel to assist in rescue and recovery operations in the event of an emergency or disaster, such as an underground fire or explosion. Over the years, the education and training of miners in the performance of their tasks has become an integral part of disaster prevention. Mine rescue training has been an important phase of this education process, for it provided a basis for the safe, efficient rescue and recovery methods that were needed following mine fires and explosions. Trained personnel, readily available in the event of a disaster, are vital in the development of an efficient mine rescue team. The training in rescue and recovery procedures includes the use and maintenance of self-contained breathing apparatus and the proper use of gas testing devices. Experience has shown that efficiency in mine rescue training can be promoted by having mine rescue crews compete in mine rescue contests. Such contests are conducted on a local, regional, state, or national scale to stimulate interest in mine rescue training. Now let us join the teams as they wait their turn to work a mine rescue problem, where conditions are simulated similar to those that might prevail after an actual mine disaster. After a team is registered, their position in the contest is drawn by lot. Then the team members are isolated until they begin working the problem. The problem is provided in two parts. First is a short objective-type written examination. Secondly, a team is required to work a simulated underground mine emergency situation. Before proceeding underground, actual or simulated, a team obtains all the necessary information on various facilities and makes arrangements to ensure their safety. The judge instructs the team and gives the members a chance to ask questions before he delivers the map and situation to the team captain. The team then usually discusses among themselves the procedures necessary to work the problem. To save time and prevent duplication of effort, team members are assigned specific tasks to perform while they are working underground. All gas testing devices, methane, carbon monoxide, and oxygen detectors are checked to ensure proper operation before going underground. After the stretcher has been tested, the extra oxygen breathing apparatus will be checked and then fastened securely to the stretcher. When the team has put on their oxygen breathing apparatus, the captain inspects each member's equipment to assure it is functioning properly and that all oxygen bottles are sufficiently filled. One team member is then assigned to inspect the captain's equipment in a similar manner. After this inspection, the captain clocks in and the team is ready to begin. The team members assume their places in single file behind the captain about 6 feet apart. When they enter the mine portal, the captain checks the roof and ribs and the mine air for contaminants. After he has completed these tests, he will place his initials and the date at a conspicuous place on the mine floor, face, or ribs. The team demonstrates proper mine rescue procedures as they enter the simulated mine and begin working the problem. Cards indicating objects or conditions were placed in advance at various points along the entries. Each team member knows what to do and how to do it. Their methods follow the time-tested routine developed to ensure the safety of all who were involved in the rescue situation. After a descriptive card is encountered and read, the information on it will be posted on the mine map precisely in the same location where it was found in the mine entry. The captain's initials and the date are recorded at stoppings, at the furthermost point of travel, and at the faces of all places visited. Teams competing in a contest are not informed in advance of the details of the problem to be worked, so that whenever any equipment or other items are found, it must be noted accurately on the team's map. The team's safety is of prime importance. Therefore, as they travel through the mine, they also inspect carefully the side entries to assure that they will not be bypassing a dangerous condition that would affect rescue and recovery operations. Tests for methane, carbon monoxide, and oxygen deficiency are taken at strategic places throughout the exploration. If the team encounters gas, they are required to note the kind and the amount of gas present. Victims' bodies, which may be represented by cards or dummies, are not removed until the fresh air base is advanced beyond the point where the bodies were found. For any survivors who are found that cannot walk, a stretcher is provided. Survivors who can walk are outfitted with the necessary safety equipment before they are assisted out of the mine. The survivors are escorted out of the mine by the shortest, quickest, already explored route. The team advances or retreats in an orderly fashion. When they reach an area where tests are necessary, they will stop upon signal from the captain. The number 5 team member will convey the signal to the fresh air base. When the team finishes the problem and reaches the mine portal, the captain stops the timing device, indicating the team's completion of the problem. The team's map will then be turned over to the judges for grading. As one team finishes, another team will follow the same procedures and take their turn working the problem. The incidence of mine disasters has decreased, but the hazards that cause them are ever present in underground mines. The need for prompt, correct procedures to save lives and to safeguard those in rescue work and to prevent further property damage after a disaster strikes a mine emphasizes the importance of having qualified people available to engage in rescue and recovery work. Training teams for emergencies, including frequent practice and participation in mine rescue contests, are excellent means of stimulating interests and maintaining the pride and proficiency of a mine rescue operation.